Optical fiber probe-based manipulation of cells. Schematically shows the formation and regulation process of an E. coli cell chain. After E. coli cells trapped one by one, a cell chain consisted of 6 E. coli was organized at the probe tip. By adjusting FB2 to approach E. coli 5, the cell is rotated and orientated toward the axial direction of FB2. Then, E. coli 5 is removed from the chain with the cell contact sequence changed. By shifting FB2 along the plus direction, E. coli 5 is put between the E. coli 3 and 4, C. After turning off the laser in FB2, E. coli 5 is gradually rotated and orientated along the axial direction of FB1, D, changing the cell contact sequence again. E schematically shows the experimental setup. After sheathed with a glass capillary, FBs 1 and 2 were fixed on microstages 1 and 2, respectively. The probe tips were immersed in the E. coli solution, while their ends were connected to the lasers 1 and 2, respectively. The wavelength of both lasers is set at 980 nanometers due to the low absorption for the biological cells. Such a wavelength induces little optical damage to bacteria and mammalian cells. The E. coli solution was dropped on a glass slide with an injector. The slide was mounted on an XY manual translation stage, resolution, 50 nanometers, to achieve fine positioning and mechanical stability. An optical microscope incorporated with a charge-coupled device, CCD, was used for the real-time monitoring, image capturing, and video recording. Schematic of the regulation process and experimental setup. A cell chain is organized at the tip of FP1. B. By manipulating FP2, E. coli 5 is rotated and then removed from the cell chain. C. E. coli 5 is added back at a new position into the chain. D. After turning off the laser in FB2, E. coli 5 is orientated along the axial direction of FB1. E. Schematic of the experiment setup. To demonstrate the operation mechanism, a dynamic regulation of the cell chain was experimentally conducted. After the laser beam injected into FP1, P1 equals 30 milliwatts, at T equals 0s, a cell chain was organized at the probe tip, which was consisted of 10 E. colis. Then, FB2 was adjusted to approach the downside tip of E. coli 3, indicated by the yellow dot, in the cell chain, A. After turning on the laser in FB2, P2 equals 50 milliwatts, the downside tip of E. coli 3 was trapped by FB2, B, with a shift of 1.9 m along the minus direction, the downside tip was shifted along the minus direction, while the upside tip, indicated by the red dot, remained stationary, C. After that, E. coil 3 was rotated clockwise and gradually orientated along the axial direction of FB2, D, then, it was removed from the cell chain and shifted along the minus direction. After that, FB2 was shifted along the plus direction with a distance of ~1 m, E, followed by a shift of 9 m along the plus direction, F, then, E. coli 3 was added back into the chain between E. coils 4 and 5, G. After the laser off in FB2, E. coli 3 was reorientated along the axial direction of FB1, and the contact sequence was changed to 1 2 4 3 5 6 7 8 9 10, H and I. Optical microscopic images of adjusting the cell contact sequence. A. FB2 was adjusted to approach E. coli 3. B. D. E. coli 3 was rotated and then trapped by FB2, who. E and F. E. E. coli 3 was shifted with FB2 along the plus E and plus direction. GI. V. coli 3 was added back into the cell chain. The two tips off. Coil 3 were indicated by yellow and red dots. To quantitatively interpret the above experiment, the optical torques, T, on the E. coli were calculated in the regulation process, which is defined as where res the position vector pointing from the central point of E coli to the interaction point, Femis the electromagnetic force element exerted on the interaction point I. Fe can be expressed as where d cis the surface element surrounding the cell, niche the surface normal vector, and Tm is the time-independent Maxwell stress tensor. The optical torque along the plus direction is defined as positive, under which the cell will be rotated counterclockwise. As shown in, the torques are positive and negative in the regions I, -50 degrees,